Hello Precalculus student, this video is for chapter 5.3. We're going to deal with fundamental identities. So we define a trig function with a unit circle. So let's review it. Here, I think in 5.2, we define it this way. Let's look at this again. So we say the terminal side will intersect with the unit circle at a terminal point, xy. Whereas sine t, the input, which is the unit circle itself, which is the angle in the center itself, is equal to y. Cosine is equal to x. Tangent is y over x. Cosecant is 1 over y. Secant is 1 over x. And cotangent is x over y. So if you, I think I mentioned this before in the original definition of trig function with r, that sine and cosecant are kind of related in that they're reciprocal of each other. Cosine and secant are related to each other by that they are reciprocal of each other. Tangent is also reciprocal of each other. So the first identities that we want to talk about is called reciprocal identities is cosecant is 1 over sine, or you can also do sine is 1 over cosecant. Secant and 1 is 1 over cosine, or cosine is 1 over secant. Cotangent is 1 over tangent. Tangent is also 1 over secant. Now, this only works if, of course, tangent theta is not 0, or cotangent is not infinity, right? So there's some restriction on it. And because tangent is y over x and y is sine, so we can actually have a quotient identity called tangent, that say tangent theta is actually sine over cosine. Sine t over cosine t. Cotangent is cosine t over sine t. So these are called, in this book, is called fundamental identities. Some other book call it reciprocal identity and quotient identities. So these are the identities that is directly from the way you define them. So for example, if I want to find cosecant 7 pi over 6, what I'll do is what? I would notice that this is cosecant. I have to do 1 over, I can use the identity to find it as sine, right? It's related to sine 7 pi over 6. And I know 7 pi over 6 is over here with the point, what is this point? X is negative, is negative with 3 over 2, comma 1/2. So sine is 1/2. So cosecant 7 pi over 6 will be 1 over 1/2 and is equal to 2. Okay. Cotangent 5 pi over 4, I think I talked about those earlier, would be here, right? But it is the ratio of sine, cosine t and sine t. So I can read it off and then do the cosine, which is x and over y. So these are, you know, how you do. Okay, maybe we'll just do, oh no, this 5 pi over 4 is not here. I don't know what I'm saying. Oh, so erase it, erase it. 5 pi over 4 should be in the third quadrant, right? Because it's actually pi plus pi over 4. So this is negative root 2 over 2, comma negative root 2 over 2. Whereas sine 5 pi over 4 is negative root 2 over 2. Cosine 5 pi over 4 is also negative root over 2. So cotangent of 5 pi over 4 would equal to 1. They're identical. Well, actually, you don't really need to use these identities, but you could if you don't remember. What the initial definition simplify. So that particular things can help us to simplify the expression in some expression into one trig functions. Now, in Math 187 in the pre-calc course 2, you do a lot of these. So this is kind of like the basic. So if you know this identity, you can simplify something that is very complex into one trig function. For example, sine t times secant t. What is sine t? That's sine t, sine t. What is secant t? I can rewrite it as 1 over cosine t. Multiplied together, that is equal to sine t over cosine t. Do you recognize what sine t over cosine t is? You can write it as tangent t. So that's one function. I divide tangent t by sine t. Can I simplify into one trig function? So I can write sine. So this would be equal to tangent t times 1 over sine t, right? Tangent t can be written as sine t over cosine t times 1 over sine t. Anytime you divide something, is like you divide by 2 is multiply 1/2, right? So cancel, that's 1 over cosine t. But what is 1 over cosine t? That's secant t. So if you divide this, it's equal to 1 trig functions. The next is Pythagorean identities. Because the way we define sine and cosine is cosine theta is x, sine theta is y. So if I plug this into the unit circle equation, x squared plus y squared is equal to 1, right? So this is actually the equation because the way you have those points would be those points on the unit circle is also on the unit circle. So any cosine square plus sine square is equal to 1 where the two angles are the same. So if you have any angle, like if this is 2° square plus sine 2° square is always 1. If you have cosine 5° square plus sine 5° is always equal to 1. So this is called the Pythagorean identity. It's called Pythagorean. Why? Because, so we can check. X and Y are part of a right triangle that we create. So let's just pretend 1.7, right? Sine square this plus cosine 1.7, also square it, add together is 1. I can change it to 88. 88 is 1. So any angle, so long as the same angle you put it in, is always 1. There is a notation that I want to mention. So when we write cosine square and sine square, we write it this way, right? Because it's the whole cosine answer. You're not squaring the angle. You're squaring the result of cosine and sine. We, instead of, writing it very clumsily, where, because we don't usually write the parentheses here. So when we do square, it's very confusing as if you are squaring the angle or squaring the sine. So we should, by default, we do it this way. But it's very clumsy to always do parentheses. So there is a shortcut of writing cosine theta square as cosine square theta. Yeah, now you're not squaring the angle, and this is not a new name of a cosine or new name of a function. It's just cosine of this angle, but you square it. So cosine theta square is now officially written as cosine square theta. So when you see someone writing it this way, it just means this. Okay, so sine square theta is equal to 1. It's called the Pythagorean identities because when we have the angles, when we have the unit circle intersect with the terminal side, so this is the x and y, you can use the x and y to create a right triangle. This is y and this is x. So x squared plus y squared is equal to 1. 1 is the radius, so that's y. And then we can also have something called the alternative forms of the Pythagorean identity, and they are very useful. 1 plus tangent square is equal to cosecant, is equal to secant, and cotangent square plus 1 is equal to secant. How do I derive them? You derive them this way. So the main one is cosine square plus sine square theta is equal to 1. If you divide all of them by cosine, right? So it's just like balance the equation. It's the same equation. So this would be 1. This would be tangent, right? Do you see that it's tangent square theta? It's like tangent theta square. And what is 1 over cosine? Is secant. So that's why we have the first one. This is the one. And likewise, I can divide the original cosine square theta plus sine square theta by sine square over sine square. So this would become a cotangent square theta. If you look at the definition of cotangent, is cosine over sine. So this is cotangent plus 1. 1 over sine is cosecant square theta. Yeah, so that's how these two alternative form of the Pythagorean identities. You may ask Ms. Chen, if you divide this, you can divide it if cosine is 0. When cosine is 0, then sine is 1. If sine is 1, tangent is also 1. Okay, so that still work. Okay. Yeah, those special case still work. So in general, we say that. So we can use those identity to do some calculations. These are kind of like drill question to get you used to the identities, right? So let's do it. But they involve doing square root of a fraction. So you need to know how to do square root of a fraction. Sine t is 3 over 4. Also, t is in quadrant 2. So find the other 5 trig functions. So remember the all student take calculus, So sine is in quadrant 2. So sine is positive. So this is sine. So it's in quadrant 2. So, but you will know that only sine is positive. And also its reciprocal is positive, but cotangent, tangent, cosine are negative, right? So this is the reason why they tell you where it is, because when you say sine t is 3 over 4, the t can be in both 1 and 2. So now we want to find the other 5 trig functions. So of course we would use the Pythagorean identity. So sine squared t plus cosine squared t is equal to 1. Sine squared t is 3 over 4 square plus cosine squared t, we don't know, we want to find it. That's equal to 1. So cosine squared t would equal to 1 minus 3 over 4 is 9 over 16, right? So then we would say common denominator 16, 16 minus 9. So it's 7 over 16, right? That is cosine squared t, right? So, and then what is cosine t then? Take square root. Do I have to do plus and minus? You have to actually do only one. Now in quadrant 2, cosine is negative, so you actually have to say negative square root 7 over square root of 16, which is 4. So you square root top and bottom, and it's negative because t is in quadrant 2. It is cosine must be negative. So have sine, have cosine, and then I need tangent. What is tangent? Tangent t is sine over cosine, 3 over 4, over negative root 7 over 4. The over 4 cancel. So tangent t is negative 3 over root 7. Rationalize it as negative 3 over root 7 over 7. So I have the 3 main ones. So it's very easy to do the other one. Cosecant t is 4 over 3. Just do the reciprocal. Cosine t is here, so I have secant t is equal to 4 just with negative root 7. You can equal to rationalize it 7 over 7 negative. And then cotangent t would be reciprocal this, but I don't reciprocal the final one. I reciprocal this one because it will be negative square root 7 over 3. I have less work to do. So another example is similar. So let's see if I can finish it. I have 1 minute. So tangent t is equal to 12 over 5. T is in the first quadrant, so everything is positive. That's very good. Find the other 5 trig function. So I can do the 1 plus tangent square equal to secant square, right? Secant square t. So this would be 1 plus 144 over 25. Common denominator is 25, 144 plus 25 equal to secant square t. So secant square t would be 169 over 25 equal to secant square t. To a square root, so that would be a square root of 165 over 25 is 169. 13 over 5 equal to